Howdy, this is Peter with Raptor Power Systems. Today I just want to walk through a quick demo of the Raptor Connect software that runs on all our PDUs and UPSs. I want to run through outlet control and current monitoring and just a simple API script that could show you sort of the potential of what you can do in your day-to-day operations using the API. So here you can see I have the Crypto Slayer hooked up. The interface is similar to all of our other interfaces, whether you're running a Crypto Beast or a custom unit or a Crypto Hub. With the exclusion of the Crypto Hub, basically the only thing that changes is if you have more outlets, say on the Crypto Beast, of course you'll have more outlets. If you have sensors, voltage sensors, power factor sensors, etc., those sorts of things will show up here under sensors in a similar interface to the relays. But this unit doesn't have any additional sensors other than the current sensors on the outlets. Now, as you can see, I've got all the outlets on right now. I'm going to go ahead and turn them off. And you can see I can just toggle outlets in much of the same way that you would expect just by clicking them. Occasionally there is a delay here, so you do want to be a little bit careful. You don't want to click too fast because occasionally there can be up to a delay of about 1 second, and that'll happen, and we'll see that I'm sure in this demo, so you can see what that looks like. But I can turn on all the outlets by hitting master on, and you can see that delay there. It's not always on the master on, but you see that delay turning it on. I can turn them off, back on, and of course I can control individual outlets. A sort of nifty thing with this interface is that everything is in fact real-time, synced between all the different control planes you might have on this device. So what I'll do is I'll show you sort of interacting with it from another pane. The way to think about it is that each interface is just a pane of glass that shows you the real current state of the PDU or UPS. So right now I have Charles here, and he has on his phone here the remote interface of this unit pulled up, the web interface, and I'm going to go ahead and have him toggle outlet 0 a couple times here, and you'll see as it happens on his interface, it's also happening on my interface in the web. Now if I were to do the same thing, say I shut off all the outlets, you'll see that's reflected immediately in his interface. If I turn them back on, that's the same thing. If I go into, for example, say RCL here, and do the same thing, if I say relay off master, you'll see that it is immediately reflected in every interface. And again, there can be up to about a second delay, but for the most part it's just real time. So that's control through the web interface. That shows you sort of how those real-time facilities operate. What I also want to do is run you through just a sample API script so you can see sort of the possibilities with that. Now, a lot of these things that you might program in the API eventually will be part of our automation framework, which is still in development and isn't really ready for public release. But to start with, you can develop a lot of these things through the API, and the API will always be available. That way you can extend it to functionality that isn't included in the automation framework. For example, if you wanted to have your PDU respond to SMS, if you wanted to be able to send a text to your PDU to shut everything off, you'd absolutely be able to do that through the API. If you wanted to say you monitor the output, monitor the hash rate of say a miner, and have an outlet toggle to sort of restart a miner if the hash rate starts to fall, that would be totally possible with the API. So those sorts of things are what we're looking at. Today I just have a really simple example. It's in our RC examples, and that'll be available on GitHub along with the documentation for this API. This is running on the most recent version of the API, so those updates haven't been pushed out yet. But the API documentation that we've provided is similar, and you can achieve similar functionalities with that. As soon as this rolls out, you'll be able to run this example directly. So what I have here, and I'll just pull it open so you can see what I've got, is this emergency overload shutoff. So you've got circuit breakers, obviously, that'll provide that sort of safety feature, but this is just a simple example of wanting to shut off an outlet if its current goes above a certain level. So you can see here I have the URL of the Raptor Connect unit. In this case, that's a Crypto Slayer. I have the outlet number and the CT number for that outlet. I'll show you in the documentation how to get all that information. but for right now we're just taking those things as given. You have the current threshold, which I've set at 7 amps, so if it's at 7 amps I'd like it to shut off that, and then you just have the script that actually performs that function. So that script checks the API sensor status of that sensor. If I were to pull it up here, I believe I have it here, you can see I've just got that same URL here. If I refresh that, that shows the current on that outlet. If I turn it off, you can see that goes to 0. Turn it back on, it goes to the current reading. So then I'm using bash. You can use really whatever you want. Bash is not the simplest option. It's easiest to run a lot of times. If you're running Windows, you can run PowerShell or Batch, or if you prefer Python or Perl or something more reasonable, you're welcome to run those. Bash, I say, is not the best, just because some of these things you have to do really ridiculous stuff. This compare statement is silly. But in any case, it just checks if the outlet current is above my current threshold. If it is, it throws a little warning message. And after that, it runs API relay off, which is how we toggle the relay with the API. If I were to do this here, I will just go ahead and show you. I wonder if, well, I'll show you here. If I do API relay off, I'm going to say master. Let's see how our relays look now. Everything's on, so if I just run that, you'll see everything shuts off. So that's what that script will do. It'll check the outlet current. If it's above the current threshold, it'll go ahead and shut it off. So what I'm going to do to demo that for you here is I'm going to go ahead and just pull this alongside our web interface, and I'm going to set up a little Linux script that just runs that every 1/10 of a second. Now, if you don't know Linux, that's fine. You don't have to know that. You can imagine you could trigger this any number of ways. But that's running now. Now, the reason I put it at 1/10 of a second is I know that way I'm going to get the highest resolution possible. In reality, where the units are at right now, about the highest resolution you can expect on some of these things is about a second. As we improve on that software and bring that time down, you'll see those things becoming more real time. In any case, at this point, many of the times it is close to real time, but you can see a delay of up to a second in those things. So what I'll do now is I'll go ahead and just master on all my outlets, and you'll see here I've got a current of 3.8. That's not really high enough to trick or trip that 7 amp threshold. So that 3 amp load is a light box that we've got here. What I'm going to do is I'm going to have Charles go ahead and replace that 3 amp load with a heat gun. Heat guns are good for this sort of testing. They run about 10 amps, so they're pretty stable that way. And as you'll see, as he goes ahead and plugs in the heat gun, if he turns it on, you'll see immediately that outlet toggles right off. Now I'm going to have him leave the switch on for that heat gun, and I'm just going to go ahead and turn this on, and you'll see just right off, up to a delay of a second, as you see there. I'm going to go ahead and turn it off, and for example, if I turn on all the outlets at once, the behavior is exactly what you'd expect. All the outlets turn on, and then that one trips. So that's a good example of this API that you can see here, where we're causing things to behave in that way. Occasionally, we have a couple of these things that'll get resolved here as we hone down some of those sensor readings. So that's an example of the Raptor Connect software, accessing it through the API and through the web interface. If you have any questions at all, just let us know. We'd be glad to answer any questions for you that you might have. And if you have any suggestions for things that we could cover in these videos, how to do things in the web interface or through the API, feel free to let us know, and we'd be glad to cover some of those things for you.